Last time we tackled the gas chromatography, and now we will discuss the liquid chromatography, but before that, let's have some discussion regarding chromatography. So, when we say chromatography, it is an essential analytical technique used for separating, identifying, and purifying mixture components for quantitative and qualitative analysis. So, chromatography is based on the principle that each element migrates at a different rate through the stationary phase under the influence of the mobile phase. The stationary phase is a porous solid like silica or alumina, whereas the mobile phase is solvent or gas. So let's proceed on our main topic, the liquid chromatography. So liquid chromatography or LC is an analytical technique in which the mobile phase is a liquid. It is carried out either in a column or a plane. The sample with the mobile phase is passed through a column or plane accompanied by the stationary phase. And due to differences in absorption, size, partitioning, and ion exchange, different solutes will interact with the stationary phase to a different extent. Thus, components are separated by utilizing these differences. And liquid chromatography is an effective technique to separate mixtures, and it is especially effective when the mixture is colored. And even if the mixture is not colored, we can visualize it using several visualization methods like irradiating it with ultraviolet light. Let's discuss the types of liquid chromatography. We can classify liquid chromatography into 4 types based on the components of chromatography. First one is the reverse phase chromatography. Second is normal phase chromatography. Third is the ion exchange chromatography. And the size exclusion chromatography. And now let's discuss first the reverse phase chromatography. This retains a nonpolar stationary phase and polar mobile phase. Hydrophilic molecules in the polar mobile phase are transported to the column and eluted, whereas hydrophobic molecules of the polar mobile phase are absorbed in the stationary phase. So, the organic solvents, aqueous, buffers, and a mixture of water are used to elute compounds in a reverse phase column. In it, the alkali chain is covalently bonded to stationary phase particles, and the charged analytes can be separated through reverse phase chromatography by ion pairing. Second one is the normal phase chromatography. It retains a polar stationary phase and a non-polar mobile phase. So, the silica and organic compounds with cyano and amino groups are commonly used in the stationary phase. So, the organic solvents like hexane or heptane mix with polar solvents like chloroform, isopropanol, and ethyl acetate are commonly used polar stationary solvents. As well as normal phase chromatography is generally used to separate chiral compounds and cis transisomers, geometric isomers, and water-sensitive compounds. And the less polar compounds are eluted first in normal phase chromatography, whereas more polar ones last. Third one is ion exchange chromatography, is generally used to separate compounds differing in functional groups. So this is also used to separate isosomers, as well as retains the ionic stationary phase and aqueous buffer as the mobile phase. Furthermore, ion exchange chromatography separates ion and polar compounds based on their affinity to the ion exchanger. And it can be subcategorized into two types: the cation exchange chromatography and anion exchange chromatography. So, a cation exchange chromatography retains two positively charged cations, while an ion exchange chromatography retains negatively charged anions. And to further understand, ion exchange chromatography is generally used to separate organic and inorganic ions from an aqueous solution. It has the highest metric tolerance and predictable elution patterns. So, the major limitation of ion exchange chromatography is that it is limited to the ionizable group. So, the other one is the size exclusion chromatography, is also known as gel filtration chromatography. So, in size exclusion chromatography, molecules are separated based on their size and the pore size of the stationary phase. In some cases, molecules are also separated based on their molecular mass, and as well as more giant molecules are eluted first, whereas smaller molecules are last. So, in size exclusion chromatography, it is used to separate industrial polymers and proteins. And lastly, the RF value. So, when we say RF, it stands for retention factor. So, it is the ratio of distance traveled by the analyte to that of the solvent front. It is the characteristic identification value of analytes. So, the compounds can be analyzed and identified based on their RF value, or the retention factor. Retention factor equals distance traveled by analyte over distance traveled by solvent. So, for example is RF value of substances A, B, and C will be as given under RF value of A equals A over X, and B equals B over X, and C equals C over X. So now let's proceed on the advantages of liquid chromatography and the applications of it. So let's discuss first its advantages. Liquid chromatography is a cheap separatory technique to separate mixtures. Second, the flow of the mobile phase, detection of separation bands, and collection of each component is done manually. And lastly, the glass where used for liquid chromatography is readily available and inexpensive too. And after discussing the advantages, of course, we will discuss the applications of liquid chromatography. So, first, liquid chromatography is used for testing ink samples. Also, it is used in environmental analysis and cleanliness testing, as well as in food analysis and quality control. Also, it is used in the pharmaceutical industries and chemical industries. And lastly, it is used in forensic sciences and hospitals. So, I hope that you have learned. That's all. Thank you for listening and watching.